Hello everyone, welcome to this session. I've just solved this NEET test 111 today, and the paper came too late, but I've solved it right now. So in this test, what's the physics paper looks like? First of all, there are 4 questions I've regarded tough, and mainly because of the calculation effect. 19 are easy, 22 are medium. I don't agree with the answer given in 16, and in the 18 also I didn't agree with the sign they have used. So all in all, this paper is a normal difficulty, but slightly tougher than the last 2-3 tests that has come up on this app. So if I talk about the marks, so 19 and 11, let's say 30, so I think 120 would be a good score, and those who are going very good should get 160 plus score, and even in this paper. Now first question, consider a hydrogen like sample of gas whose energy in the nth state is given by this. When the electron makes transition from an excited to a ground state, most energetic photons can have energy maximum is this much and the least is this one. The atomic number of the atom and the state of excitation are. So what we can have, maximum will be when it makes a transition from n to 1. So what I can say, 13.6 z square by n square into 1 upon 1 square minus 1 upon n square is equal to 52.224 eV. Second is, minimum would be when it makes a transition from n to n minus 1, that we can make it out as 13.6 z square by n square is 1 upon n minus 1 whole square minus 1 upon n square. That comes out as what it comes out, it is 1.224. So now zn are the two variables, you can solve them. First thing is you can divide them. So if I divided 1 minus 1 by n square upon 1 upon n minus 1 whole square minus 1 upon n square is 52.224 upon 1.224. if it is perfectly cancelling up, let me check, we'll check sometime later. So what we can do right now, just try to simplify it, n square minus 1, and it will come out as n square minus n minus 1 whole square, and then n square will cancel up, but n minus 1 whole square will remain. That is 52.224 upon 1.224. So what we have now, this is n square minus 1 above, so n plus 1 into n minus 1 into n minus 1 whole square upon, this will become n minus 1, that is 1, and n plus n minus 1, that is 2n minus 1, that you can write, that is 52.224 upon 1.224. This is going to be too much calculative, I suppose, because nothing is getting easier, so it's not an easy equation. But if you solve it as per this, I'm not going to take it for you, it would be better to attempt it in the last. On solving, the n will come out as 5. You can put the values, let's say 3, 4, 5, and check. That would be the only thing I can suggest. For example, if you put it 3, it would be 4 into 2 upon 4 divided by 6 minus 1, 5, that is 4 to 4 by 5, that is 4 4s are 16, 32 by 5. Definitely it is not going to be like this. So you can try and check n equal to 5 and put n equal to 5, you will get z equal to 2, and you can do from calculation. I'm not doing the complete calculation because it's not that easy here. Next one, the period of revolution of an electron in the ground state of a hydrogen atom is t. The period of revolution in the first excited state would be, so again you can say time period is 2 pi r by v, that is proportional to r by v, that is proportional to n square by z, proportional to z by n. So it means it is proportional to n cube. So in the first excited state it will become 8t, because n becomes 1 to 2. Directly you can go for 8t here. Next one, 500 kg rocket is set for vertical firing. Exhaust speed is 800 to give an initial upward acceleration of 20. The amount of gas ejected, so let's say let it be m dot. So m dot into v relative would be equal to mg plus a, because mg will also be acting downward. So that the thrust force minus mg is ma. So that m dot, or the mass ejection rate, would be m is 5000, g plus a becomes 30, and this is vr is 800. So these two 0 goes. So what we are left with, 50 into 3, that is 1500 by 8. So it would be roughly, if you can solve it, it would be 1 and then 8, and that would you have 70. 70 means 8 8s are 64, then 60, that is 187.5 kg per second. That is the answer that I am getting. So go for option D in this case. Next one, bullet of 50 gram fired from a gun of mass 2 kg. Total kinetic energy is 2050. The kinetic energy of the bullet and gun is, because it is fired, both will have equal momentum. So what I can say, k bullet to k gun, that ratio would be mass of gun to mass of bullet. That is, gun mass is 2000 grams, this is 50 grams. So it comes out as 40:1. So what I can say, the kinetic energy of the bullet would be 40 upon 41 into 2050 joules. So if I do this for this would be slightly lesser than 2050, more likely that number, so go for option B. It would be very close to 2050, so you can directly go for this one, and you solve it also, it will come out like this. Two particles are moving on a circle at a certain instant at time. Both the particles are diametrically opposite and P has a tangential of 8 and centripetal of 5, while Q has only centripetal of 1. So if I can see it, let's say if I draw it like this, let me go like this, let's say both are diametrically opposite. P has an acceleration, centripetal would be 5 here, it would be 1 here, and it's 8 here. So if I do this relative, this will become 5 and 1, 6, 6 and 8, so the resultant would be under root 6 square plus 8 square. I can directly go for 10 meter per second square. It would be the relative acceleration. Now the next, sixth, magnet of moment M is in the form of a quadrant of a circle. If it is straightened, its new magnetic moment will be. So it is in the form of a quadrant. Quadrant means this is 90 degree. So it is in this form, and let's say this is R and R. So I can make it out, the distance between the poles is root 2R and the length is pi R. So now it is having M when the pole separation is root 2R. So when it becomes pi by 2R, sorry, this quadrant length pi by 2R. So what would be the M dash? So M dash directly I can say that would be M upon root 2R into pi by 2R, because it is proportional to the length. So R and R goes, so it is pi upon 2 root 2 times M. So which comes out as option D here. Go for D. Next one. Heater coil is cut into 2 equal parts and only one part is now used in the heater. So that means the length is half, that means the resistance has become half. So power equal to V square by R, because voltage is fixed. So R is half, that means power becomes twice. So power becomes twice, so the heat generated will now be doubled. You can go for option C here. In the circuit shown below, the voltmeter is of large resistance. That means you can say take it to be ideal. The EMF of the cell is E. The reading of the voltmeter is going to be. So the voltmeter read is the potential difference between the points A and B. So what we can do here, the EMF of the cell is given as E, what it is going to read. So we have, there will be no current going this way almost, and no current going this way also. Only the current will be going like this in these two loops, like this and like this. So what we'll have here, the drop would be 4 by 10 of E, and here the drop would be 6 by 10 of E. So the difference, if I do, that would be 2E by 10, so it would be E by 5. I can directly make it out. Go for option C. You can do it like that. Next one. 100 volt AC source of frequency 500 Hertz is connected to an LCR circuit. L given, C given, R given, all in series. What is a quality factor? So you need to remember this quality factor. So quality factor, one way is 1 upon R root L by C, if you remember. So 1 by R, R is what, 10, root L, L is 8.1 into 10 to the power minus 3, this is 12.5 into 10 to the power minus 6. So it is 1 by 10 and it comes out as 8100 upon 12.5. You can do it like this. So it would be, if I do this, would be, I think close to 60 and something. So 60 will be 60, okay, no, not 60, yes, 600, sorry. So it would be 600 or 700. So it would be 25 something, slightly greater than 25 by 10. So it would be 2.54 is the most appropriate I can go for. Looking at these options, this is only possible here. Next one. A coil having inductance L and R is connected to a battery of EMF at T equal to 0, T1, T2 are the times for 90 and 99% completion of the current growth, then T1, T2 would be. So what we can say, I is I naught e to the power, what we write, 1 minus e to the power minus TR by L. So for 90%, this becomes 0.9 I by I naught, that is 1 minus e to the power minus T1 R by L, and 0.99 means 1 minus e to the power minus T2 R by L. So from above, what we get, e to the power minus T1 R by L is equal to 0.1. So T1 R by L is equal to Ln 10. So T1 is L by R, Ln 10 you can write. And similarly, what we can have, e to the power T2 by RL minus T2 by RL will come out as 0.01, or we can say T2 R by L, sorry, it is not written proper. So this is T2 R by L. If I inverse it is ln of 100, ln of 100 you can write it as 2 ln 10. So this T2 comes out as L by R into twice of ln 10, that you can say is twice of T1. So the time ratio would be 1:2. Go for option A in this case. Next one. the total electrostatic energy stored in both the capacitors will be, so what you can say, the total drop is 3 volt, the C equivalent would be equal to in series, that is 2 microfarad. So the energy stored is half C equivalent 2 microfarad into V square, that is 3 square, that is 9, that is equals to 9 microjoules. Go for option A, you can directly do this. Next one. Hollow charge metal sphere, radius r, potential difference between the surface and a point at a distance 3r from the center is V, then the electric field intensity at distance 3r from the center, again it is a repeated one. What we can say, V would be equal to kq by 3r minus kq by r, because at outside point we write it like this, so it comes out as 2 kq by 3r, and the electric field at 3r would be kq upon 3r whole square, that is 9r square. So I can write this kqr as 3vr by 3vr by 2. If I write it divided by 9r square, this r and r goes, this basically comes out as v by 6r. So go for option A in this particular case. Next one. Figure shows the elliptical orbit of a planet M about the sun S. The shaded area SCD, this area is twice the area AB, so time will be doubled. You know that because the aerial velocity is same. So T1 is this time and T2 is this time. I can directly say T1 is equal to twice of T2. Go for option B. That's an easy one, basic application of the Kepler's second law. The magnitude of binding energy of satellite is E and kinetic energy is AK E. So what we can say, the binding energy is minus gmm by 2r, you know, and kinetic energy, you know, is equal to plus gmm by 2r. So ratio of the magnitude is going to be 1 magnitude we are taking, that is 1. Next one. Calculate the temperature at which a perfect black body radiates at a rate of 1 watt per centimeter square. So H is a sigma black body, E is 1 A to T to the power 4. So 1 watt per centimeter square, so that is H by A. So H by A is given, that is sigma T to the power 4. So T to the power 4 would be 1 watt per centimeter square. So if I convert it into let's say, okay, so it is better to convert into the SI unit. So it is 1 upon 10 to the power minus 4 we can write, and this sigma, if I divided it would be 5.67 into 10 to the power minus 8. So T to the power 4 comes out as 10 to the power 12 upon 5.67 to the power 1 by 4. So what we will have, 10 by 3 divided by 5.67 to the power 1 by 4. So you can make it out, it would be less than 2, 1 point something and 1000 upon 1 point something. That means this would be greater than 500 for sure. And if you do it exactly, now it's a tough ask to do. It's not that easy to cover up. Now you have to do by hit and trial type thing. I can't help much because it would be tough to find now. So if you do this, it would be 1.5 something if it come, because if you do 1.5 to the power 4 is less than 5.67, 1.6 is greater, so it would be between 1.5 and 1.6, and if you do, it comes out as 648 Kelvin, though not easy to solve in the examination hall because options are not that far here also. The work done in kilojoule by the gas in the following cyclic process will be, so what it would be. So work done, because we have this PV, we need to calculate this area. That doesn't matter because this axis or this axis, the axis shifting doesn't matter here. So the area of this would be pi AB. I treat it as a ellipse because both have different units. So A is this is 10, that is 5 bar. Bar means, let's say 10 to the power 5 approximately you can do, and this is 16 and 2 minus 2 14, that is 7 into 10 to the power minus 3 for a standard units, that is 35 pi into 10 to the power 2. So 3500 pi you can make it out, and if you will see like this, here the volume is decreasing and this area is more, so I can go for negative sign. So work done here would be negative, so minus 3500 pi, so that would be closer to this minus 11,000. We can go for this particular, okay, it is in kilojoule is asked, so it would be minus 11. So we'll go for this option. I don't know why they have given plus 11, it would be minus 11 because volume decrease part has the more work done in this case. Next one. A Carnot engine having an efficiency 1 by 10 as a heat engine is used as a refrigerator. If the work done on the system is 10, the amount of energy absorbed from the reservoir at a lower temperature is, again we have done it many times, I know this in 90 joules, I am not going to solve it. If you wish, you can do this one minus Tc by Th and find Tc by Th, that is Qc by Qh, and from there you can calculate this whole thing. Wires 1 and 2 carrying currents I1, I2 respectively are inclined at an angle theta to each other. What is the force on a small element dl of wire 2 at a distance r from wire 1 due to magnetic field of wire 1. So due to the magnetic field of wire 1, the field will be inwards and it is perpendicular to this dl, so directly it would, so force would be b1 I2 into dl. Now what is b1? b1 would be mu naught I upon 4 pi r. One would be cos 0, but other one angle is given as cos theta, so it would be 1 plus cos theta. So mu naught I upon what we have 4 pi r, it would be 1 plus cos theta that we are going to write here into I2 into dl that we will be writing. So none of the options is matching, and if I checked it in the books, it is given they have taken this angle also as theta, so then it becomes 2 cos theta and you get this formula, this one. But still I don't go with this because I can't see why it would be theta, because the other end would be very very far away. So for me, no answer from my side. Okay, next one. 3 rings each having equal radius r are placed mutually perpendicular to each other, each having its center at the origin. If I is flowing through each ring, then the magnitude of the magnetic field at the common center, we will say all 3 will feed equal magnitude but perpendicular to each other, so we can directly have root b square plus root b square plus root b square, that is root 3b, and b at the center you know is mu naught I by 2r, so it is root 3 mu naught I by 2r. Go for option A in this case. Next one, the speed of a body moving with uniform acceleration is u. The speed is doubled while covering a distance s. When it covers an additional distance s, its speed would become, so what we can say, because acceleration is constant for first distance s, time would be more, for next distance it would be lesser. So in the first it doubles, that means it changes by u. In the second it would be less than u would be the change, so it would be less than 3u. So less than 3u, we are left with 3 options. So let's apply the equation. First what we can write, this is 4u square would be equal to u square plus 2as for the first one, and if we can apply for the final speed, let's say v square, initial to final, it would be u square plus distance would be doubled. You can write it like this. So what we have, v square is equal to u square plus 4as, and here from the above equation I can use 2as as 3u square, so that will become 6u square, so v comes out as root of 7u. Go for option D in this case. Next one, body projected horizontally with 20 meter per second. The speed of the body after 5 seconds is, so we know ux will be vx, vx will remain 20, and vy will now become gt, gt means 50, so the speed will become, final speed v would be 50 square plus 20 square, that is 2500 plus 400, that is 2900, so it would be 10 root 29, so it would be in 50s, it would be 54 meter per second. That would be the most appropriate. Next one, wooden block of mass m resting on a rough horizontal table is pulled by a force F shown. If mu is the coefficient of friction, its acceleration would be, so what we can do, this would be the normal, this would be mg, and this would be friction. So first of all, normal will be n plus f of sine theta equals mg, so n is reduced, n becomes mg minus f sine theta. So the acceleration would be f cos theta minus f, f is mu kn, n is mg minus f sine theta divided by m. So look at the options, as per the options only C is coming out to be the one that could be possible. Go for it. Next one, light string passing over a smooth light pulley connect 2 blocks m1 m2. If the acceleration of the system is g by 8, the ratio of the masses, you know, acceleration is m1 minus m2 upon m1 plus m2g. In this standard case, this is given as g by 8, so g by 8 is m1 minus m2 over m1 plus m2 into g. So what we get, m1 plus m2 is 8m1 minus 8m2, so what you will be left with, this is 7m1 is 9m2, so the ratio is 7:9 or 9:7, whatever you can write, that would be the answer. In a radioactive material, its activity at T1 is R1 and at T2 is R2. The decay constant of the material is, we did it in the question that we did in the revision series today. So this R1 would be equal to, what we can say, that would be equal to lambda times N1, R2 would be equals to lambda times N2. Okay, and the decay constant of the material will be, so what I can directly make it out, the decay constant of the material would be, I can treat it as this, you can write it as you can write r naught e to the power minus lambda t1, you can write it as r naught e to the power minus lambda t2, it would be the better way. So r1 by r2 comes out as e to the power, it comes out as minus lambda of t1 minus t2. So r1 is r2 e to the power minus lambda t1 minus t2, that would be the answer. So go for option B in this particular case. Next one, mass of lithium is 0.042 less than the sum of all the masses of the nucleons. The binding energy per nucleon, this I give you as test yourself question in that revision series. So the binding energy, first of all, I can make it out, would be 0.042 into 931.5 MeV. So binding energy per nucleon would be that divided by 7. So if you going to do this, this is 9 4, you have 36, or you can say this is approximately 40 by 7. So it would be 40 by 7 approx, so it would be 5 point something. That would be the most appropriate one out of all these MeV per nucleon. So go for option B, you can solve it. Next, a 5 kg mass bounces in SHM at the end of a spring, at which point the acceleration of the mass is the greatest. Okay, bounces at the end of a spring when the spring is fully compressed, when the spring is fully, so acceleration is greatest at the mean position, that is it is 0 at that. So acceleration is maximum at what you say at the extreme. So when the spring is fully compressed and when the spring is fully stretched, that is the extreme position. Go for it. Next one, for SHM, the potential energy is equal to kinetic energy. We say kinetic energy equals potential energy. If I draw this curve, let's say one comes like this and the one comes like this. So this is one cycle. We say in one cycle they will be equal at least 4 times, so it would be 4 times during each cycle. Actually they are equal at a by root 2, so a by root 2 plus will be attained 2 times, minus a by root 2 also attained 2 times, so it would be 4 times. The work function of a substance is 4 eV, the longest wavelength of light that can cause photoelectric emission, that is the threshold wavelength. So 4 would be 1240 by lambda naught. So lambda naught is 1240 by 4, that is 310 nanometer. That's a very easy one for you. When the light of 300 nanometer or less falls on an emitter A, photoelectrons are emitted. For B, 600 is sufficient. Then the ratio of the work function. So here double wavelength is doing this, that means its work function is half. So 5A to 5B is 2:1. Directly you can go inverse of wavelength threshold. Solid ball of density ρ1 and radius r falls vertically through a density of liquid ρ2. Assume that the viscous force is this, k is constant, v is what is the terminal velocity. So what would be the terminal velocity? So at terminal velocity, viscous force would be kr vt plus the fluid's buoyancy, that would be ρ2 into 4 by 3 pi r cube g would be equal to ρ1 into 4 by 3 pi r cube g. That is the standard one you typically write here, that because of that 6 pi r neta v, 6 pi neta has become k. So going by this vt comes out as what I can write, ρ1 minus ρ2 4 by 3 pi, it will become r square g, that r will cancel upon k. That would be the answer that we would be getting here. So as per this option, A will be the answer. Next one, when a glass capillary of radius 0.015 is dipped in water, water rises to a height of 15 within it. Assume the contact angle to be 0, the surface tension is directly, you can write 0, so H is 2s upon rho Ga. So what we have, the S would be, H is 15 centimeter, that is 15 into 10 to the power minus 2, density is 1000, G is 10, and this radius is 15 into 10 to the power minus 5 upon 2. So 1 2 3 4. So this goes, it becomes 10 to the power minus 1. So what it becomes, 15 15s are 225, 22.5 by 2. So that is coming out as 22.5 by 2, that is 11 point something that we are getting. If I am doing it right, let me recheck this. 10 to the power minus 5, okay, I cancelled it, it should be 2 and 5 7, and it was 4, so 10 to the power minus 3, so it is still 10 to the power minus 2, so 10 to the power minus 2 would be the answer. So 0.11 Newton per meter, that would be the answer in this case. Next one, to get 3 images of a single object, one should have 2 mirrors at an angle of, so we just remember, if it is at 120 degree, we have 360 by 120 will be give me 3, so the number of images in this case will be 3. So go for option C here, 120 you can have 3 images. Also at what we can say, 360 by 90 is equal to 4, that is an even integer. Here also the number of images will be 3, so it would be 90 is also correct, but since we have to give one answer, we know here one case is 2 when it is placed on the angle bisector, so there can be a possibility of 2, but here always 3 will be formed, so I'll stick with 90 would be the more appropriate. Though in 120 also you can get 3, but in 120 there's a case when it is placed on the angle bisector, it would be 2. A point object and a plane mirror and a mirror M move with velocities 3 and 4 like this. Is normal to the mirror. What is the velocity of the image? Just remember, this velocity doesn't matter as anything, it won't lead to any change, because if you shift a mirror upwards or downwards, image will be there. So we need only this one. So 4 cos 60, that is 2. So what now, one way is if you remember the expression, or the other way that I suggest is let's say this distance is x, so the image is also at a distance x here. Now after 1 second, if I check, it has moved 3 and it has moved 2, so this gap has now become x minus 5, so this will also become x minus 5. So what we have, this it has moved 3, so 3 plus x minus 5 plus x minus 5, so what we have, we basically have it as 2x minus 7. That means it has shifted by 7, so its speed would be 7 centimeter per second. And if you know that velocity's formula, you can go for this. I am not using because I assume you might not be knowing that. A body of radius r and mass m is rolling horizontally without slipping with speed v. If it rolls up to a hill to a maximum height, this the body might be. So what we can say, the loss in kinetic energy would be half mv square beta, that would be equal to mgh, because if it is pure rolling, final speed kinetic energy will become 0. So this m and m goes, so v square upon 2g is equal to, into beta is equal to h. H is given as 3v square by 4g, g gone, v square gone, so beta comes out as here 3 by 2. 3 by 2 is for disc or a solid cylinder, so go for option C here, it would be disc. Next one, a 1 rupee coin starting from rest rolls down a distance of 1 meter on an incline at 30 degree with the horizontal. The time taken will be 1 rupee coin starting from rest, so coin will be a disc, so what we can make it out, it is traveling a distance 1, so s would be equal to half at square. A is g sin theta upon beta t square, so what we need t would be 2s beta, beta is 3 by 2, g is 9.8, sin theta t is 1 by 2, that is 0.5. so what it is, 2 into 1.5, that would be 3 upon 4.9 under root, that we are getting, so it is a root of 30 upon 49, so it is 1 by 7 into root 30. So root 30 would be 5 point something, I can make it out. So if it is 5 point something, so 5 by 7 is 0.7, so it would be closer to 0.7. I can it would be it would in fact be greater than 0.7, but out of the options it would be the most appropriate, though I don't say it is the perfect one. If LED is forward biased, then electrons from n side cross the p n junction and recombine with holes in the p side type. Electrons and holes neutralize each other in depletion region. At junction, electrons hole remain at rest, none of these, so this is the most appropriate because there will be diffusion of electrons from n side towards the p sides. In a PN junction, square input signal of 10 volt is applied as shown. The output voltage across RL is, we say when it is forward bias it will conduct, so we will get a voltage, otherwise we won't get. So this is the question I have taken in that revision series also. This would be option D. This is a previous year question. Gas mixture contains an equal number of hydrogen and nitrogen molecules. Specific heat measurements of the mixture at a temperature below 150 Kelvin would indicate the value of ratio of a specific heat for the mixture as, so it is hydrogen and nitrogen, so would indicate the value of a ratio of the specific. So here you have to use that below 150 hydrogen doesn't exhibits that basically that what we say the tendencies of what we say rotation, so it only has 3 degree of freedoms while this nitrogen have 5 degree of freedoms. So the ratio of the specific heats for the mixture in this particular case, one will become mono and one will become dia, both have equal moles. So what we can say, total moles n, 2n upon gamma mix minus 1 would be equal to n upon what we mono means 5 by 3 minus 1, dia means 7 by 5 minus 1, so it comes out as 3n by 2 plus 5n by 2, that is 2n upon gamma mix minus 1, so it is a 4n 2n gamma mix minus 1, so gamma mix comes out from here as 3 by 2. So it's a good question, you need to remember, otherwise if both would be behaving exactly the same, then gamma would have been 7 by 5 in that case, but here you have to be careful about it. Out of the following 4-dimensional qualities, which one is qualifies to be called a universal constant? Acceleration due to gravity, no. Surface tension of water, we can't say. Weight of a standard kg, mass, no. Velocity of light in vacuum, that is a universal constant we use, so go for option D here. 40. In YDSE, the path difference between two interfering waves at a point on a screen is 13.5 times its wavelength. That means it is a 2n plus 1 lambda by 2. It would be a dark fringe. You can directly go for it. A wavefront is represented by the plane y is equal to 3 minus x. The propagation of the wave takes place at, that means y and x, if you check it would be, let's say it would be y plus x equal to 3 type of thing is coming. This is the wavefront. Wavefront means that is a normal. Y plus x equal to 3, it would be something like this. So if these are the wavefront, that means the light is going like this, that is 45 degree with the x direction. That would be the option most appropriate here. So go for the next one. Police car is going at a speed of 30, chases a motorcyclist. Policeman sounds horn at 180 while both of them move towards a stationary siren of 160. Calculate the speed of the motorcyclist if it is given he doesn't observe any beats. That means the frequency of this 180, what he hears, it would be 180 into 330 minus his speed v, let's say, and this is 330 because policeman is coming towards it, that would be minus 30. And because it is going towards a stationary siren of that frequency, this which is same would be equal to, I can say, 330 plus v upon 330, that we can do. So from here solve it, 0 and 0 goes, so 18 into 330 minus v, this becomes 300, this becomes 16 into 330 plus v upon 330, so 0 and 0 goes. So what we can do, I can cancel it up here also, 15 and it is 9. So what we are left with, we can do this, if I let's say multiplied it, I don't want to multiply but let it me multiply. So 330 into 33 into 9 minus 33 into 9v would be equal to 16 into 15 into 330 plus 16 into 15, the 16 into 15 would be 240, I can write 240v. So if I take that vv terms here and take 330 common here, 33 into 9, 33 into 9, if I do 30 into 9 would be 297 minus 240, that would be 240 plus 297v. So v comes out as 330 into, this is coming out as 57 and this is coming out as 7, 9 and 4, 13, 537. So what I can say, it would be slightly greater than 1 by 10, so it would be slightly greater than 33. So I think 35.02 would be the most appropriate out of all the options that we can take. Next one. Among the following, the equation which represents a progressive wave is, the progressive wave is represented by this one, a sin kx plus omega t or cos kx plus omega t, you know. Next one. Pump motor is used to deliver water at a certain rate from a given pipe to obtain n times water from the same pipe in the same time. The amount with which the power should be increased, we know that is equal to n cube. Why? Because power is basically, what you can say, it is equal to rho a v cube. So to get the double of amount of water, v should be doubled, and v should be doubled means the power should be 8 times, that you must have done many times to double. So for n it would be n cube. Very common question. Next one. Block of mass m stationary with respect to the wedge of mass m moving with uniform speed v on horizontal surface, work done by friction force on the block in t seconds is, which is the block, okay, is stationary with respect to the wedge. That means whatever be the speed it is gaining, mg is not doing any work here, so whatever be the speed it is gaining, that you can make it out would be because of this, okay, no, because normal is also there, that won't work. Let me think again. So work done by friction force on the block in t seconds. So first of all, in t seconds it will move a distance vt forward, so it has gone vt, and the friction would be acting like hit this, and friction would be equal to, because it is not slipping over it, so it would be mg sin theta, I can make it out. So this would be mg sin theta, and if I take this component here, the component here would be mg sin theta into cos theta into vt, and it would be negative. So I can write it as minus mg vt by 2, and it will become sine of 2 theta. That is what the option is given. Go for option B here. So that is also another question for you. So that was today's paper. Thanks for watching.